So continuing our little journey through resources today with topic 15.5, which is about making ammonia. Now we'll talk about fertilizers in more detail later in this unit, but the key idea for today is just that plants need nitrogen. It's an essential element in growth. It's incorporated into, well, all sorts of things, but especially protein. Protein can't form without nitrogen. Nitrogen, well, of course, plants get it from the soil. It can't get it from the air. Why not? Because it's in the form of nitrogen gas, and nitrogen, as you may remember from your covalent bonding days, it's a triple bond between the two nitrogens. It's a very strong bond. It's got a very high bond energy, which means that it takes a lot of energy to break it apart. Plants can't do it. The only thing that can do it is, well, there are certain plants, got peas and beans, leguminous plants, and clover is another one. But actually, it's not the plants, it's nitrogen fixing bacteria is what they're referred to. So there's in the roots, or little nodules in the roots, these bacteria live symbiotically in the plant, and they can turn nitrogen, atmospheric nitrogen gas, into nitrates, which the plant can use, which is why farmers used to have a crop rotation and used to leave the fields fallow for a year, and then the clover would grow and that would fix some nitrogen, and then the farmer would plough that all in, and that would reinvigorate the soil for crops growing in the following years. Nowadays, of course, where we have intensive farming, we don't leave fields to grow grass and clover for a year. Instead, we use fertilizers. So nitrogen-based fertilizer uses, well, there's two things that contain nitrogen in an available form. There's the ammonium ion and the nitrate ion. So, for example, a really simple nitrogen-based fertilizer would just be ammonium nitrate. A lot of the mass of an ammonium nitrate, of the ammonium nitrate compound, is available nitrogen. So where does that come from? How do we make nitrogen-based fertilizers? How do we turn nitrogen into ammonium nitrate? Well, for a long time, nobody had a way until about 100 years ago. German chemist called Fritz Haber came along and worked out a way of turning elements, nitrogen and hydrogen, directly into ammonia, so that the reaction in its simplest form is the reaction of nitrogen and hydrogen to make ammonia. Notice that it's a reversible reaction. That'll be important when we understand the industrial conditions that are needed for the reaction. But let's just deal with how the reaction's done first. Well, nitrogen is fairly easy to obtain. It comes from air. You have to remove the oxygen and carbon dioxide and a few other gases, but fundamentally air is 78% nitrogen, so there's plenty of nitrogen there, and it's not going anywhere else. Hydrogen's a bit harder to make. You can make it from various methods, like by electrolyzing water, but it's typically made from natural gas. There. And the first thing you have to do with the gases is clean them. They're scrubbed, again, to remove carbon dioxide and other gases that we don't want. and then they're piped into our, it would be a big factory ammonia plant. The first thing we'd need to do is sort of compress and heat the gases. So we mentioned some kind of compressor. And then they'll go into a big reaction vessel. So the reaction vessel would have layers of iron catalyst, beds of iron catalyst for the, here's my iron catalyst, for the gases to flow over. So we've got an iron catalyst here. Temperature is about 450 degrees and the pressure is at about 200 atmospheres. I'll come back to why we use those particular conditions in the next talk there. Okay, so the nitrogen and hydrogen will start to react and will make ammonia. Because the reaction's reversible, even if you had perfect conditions, you're never going to turn all the nitrogen and hydrogen into ammonia. This is reversible. The ammonia can also turn back into nitrogen and hydrogen. So even if everything goes well and 90% of your gases are turned into ammonia, we still need to separate them. So the next thing that the gases go into would be a sort of separating thing here. The way it's done is you cool the gases down. The reason this works is ammonia's got a much higher boiling point than nitrogen and hydrogen. Nitrogen and hydrogen, their boiling point's incredibly low, like minus 200 or something ridiculous like that. So if you just cool it down to minus 100 or somewhere like that, the ammonia will turn into a liquid. And then because it's a liquid, it's pretty easy to separate. It'll just fall off, just like a shower there. And then the gases, well, our nitrogen and hydrogen gases can be recycled. Okay, so that's the basic idea. Let's just run through that again. So nitrogen from the air and hydrogen made from methane gas or natural gas, piped into a container, cleaned, compressed and heated to about 450 degrees and compressed to 200 atmospheres. That means 200 times atmospheric pressure. The pressure in this room right now times 200. And then beds of an iron catalyst. Iron, of course, is a solid, so it just sort of sit on some beds. Pass the gases over that. We'll get a mixture of nitrogen, hydrogen and ammonia because it's reversible. So we then need to separate the ammonia from the leftover nitrogen and hydrogen. We do that by cooling. The ammonia is removed as a liquid. The remaining nitrogen and hydrogen are recycled and go back into the container.